I would like to begin this presentation by going over the agenda that I will be following. First, I will be providing a definition of artificial intelligence. Second, I will be going over a timeline of artificial intelligence within the healthcare community. Third, I will be addressing the issue with unstructured versus structured data. Fourth, I will define and go over subfields within artificial intelligence. Fifth, ethical and security issues with using artificial intelligence. Sixth, I will be providing 2 AI tools of interest for the We Heal Health community. And seventh, implementation strategies for artificial intelligence. What is artificial intelligence in healthcare? As defined on the website of ARM 2022, AI in healthcare is an umbrella term to describe the application of machine learning algorithms and other cognitive technologies in medical settings. In the simplest sense, AI is when computers and other machines mimic human cognition and are capable of learning, thinking, and making decisions or taking actions. AI in healthcare, then, is the use of machines to analyze and act on medical data, usually with the goal of predicting a particular outcome. AI is a big business in healthcare. The total global artificial intelligence in healthcare market is estimated to reach $95.65 billion by 2028, up from $6.6 billion in 2021. That is a growth of 47%. I would like to go over a brief history of artificial intelligence in healthcare. In 1956, the Dartmouth Summer Research Project took place and is considered the birthplace of artificial intelligence. In 1959, Ledley and Lusted developed medical informatics. In 1971, the Research Resource on Computers in Biomedicine was established. In 1972, Mycin was developed to assist physicians in diagnosis. In 1973, Stanford University developed the AI in Medicine, or AIM, computer system. In 1975, the first AIM workshop was held at Rutgers University. In 1976, the CASNet model was developed and assisted physicians with patient management. In 1986, DX-Plane was developed and assisted physicians in decision support. In 2007, IBM's Watson was developed and used natural language processing in its technology. And in 2012, AlexNet was developed and enhanced the use of deep learning. One of the advantages of using artificial intelligence in healthcare is the ability to standardize and normalize unstructured data. Up to 80% of data within electronic health records is unstructured, which is unusable to health IT systems. The result is that the unstructured data is ignored. When unstructured data is extracted manually, it is primarily used for administrative purposes, and it proves to be an increased burden on frontline caregivers. With the use of artificial intelligence, unstructured data can be converted to standardized codes, which converts this forgotten data into data that is accessible and usable. This advanced technology can result in improved care for the patient, improved efficiency for the provider, decrease costs and increase revenue for the payer, and improved policies directed toward the health of populations. Artificial intelligence has different subfields. Machine learning is a branch of AI and computer science which focuses on the use of data and algorithms to imitate the way that humans learn, gradually improving its accuracy. Machine learning utilizes supervised, unsupervised, and semi-supervised learning methods. Deep learning is a subfield of machine learning, and neural networks make up the backbone of deep learning. The deep in deep learning is just referring to the number of layers in a neural network. A neural network can consist of 3 or more layers. Deep learning and neural networks utilizes structured and unstructured data for learning. Natural language processing is a subfield of AI, computer science, and linguistics. Natural language processing is how computers process and analyze natural language data. This allows the computer to understand the content of documents and the contextual nuances of language within those documents. Convolutional neural networks are a specialized type of artificial neural networks that uses mathematical operations to process pixel data and are used in image recognition and processing. I would like to now emphasize some of the ethical, privacy, and security issues which are a part of AI applications. First, let's consider the ethical dilemmas that artificial intelligence could present. Biases could result based upon a limited scope of data that is involved with developing the AI product. Unfortunately, this could result in recommendations that are not based on an accurate representation of the population served. This bias could potentially lead to discrimination, inequality, digital divides, exclusion, and social or economic divides. Another ethical dilemma is how the clinician should effectively communicate the role and function of artificial intelligence. It is important for clinicians to clearly explain basic core technologies to patients, distinguishing the roles of the clinician and the AI device, and the potential harms for missteps and the risks and benefits of using AI. It's important to integrate ethical considerations within AI systems to ensure trust, understanding, and respect of human and civil rights. The security and privacy of artificial intelligence systems should be a top priority for the board of the We Heal Health Network. May I suggest 3 ways to improve AI security? First is transparency in how AI models are developed and tested, allowing experts to identify vulnerabilities in the technology. Secondly, improving auditing techniques that will lead and lend to more research on security risks. Third, accountability within the AI profession that will establish security and safety requirements that must be met by AI developers. Now I would like to introduce the stakeholders to 2 specific AI tools. The first is NanoX AI. NanoX AI specializes in offering medical image AI technology for advancement of value-based population healthcare management. NanoX AI technology analyzes existing CT scans from Picture Archiving and Communication Systems, or PACS, identifying common chronic diseases previously undetected. Radiologists review the NanoX AI results available in the PACS workstation. When chronic diseases are identified, results are passed to the physician, who can then initiate further medical assessment and establish individual preventative care pathways for the patient. Integrated delivery networks and payers benefit from this technology through more accurate risk adjustment, timely intervention, improved quality of healthcare services, all while significantly reducing associated costs. Return on investment with NanoX AI could look like this for the WeHeal Health Network. The NanoX AI tool will appropriately apply HHC codes for chronic conditions, resulting in an increase of payments of upwards to $20,000 per patient per year. The NanoX AI tool will identify and prevent upwards to 100 strokes within the WeHeal Health Care Network each year, resulting in a $14 million savings. The next AI tool I would like to discuss is Viz AI. This AI workflow tool is utilized by hospital networks and trained clinicians, and allows for identification and communication of patient images to specialists within the hospital network. The images are sent from a regional care team to a neurovascular specialist, who then sends notification of suspected LVO, IHC, cryptogenic stroke, CT perfusion, aneurysm, pulmonary embolism, or aortic disorders to acute care teams within the hospital network. The tool alerts care teams of suspected disease within minutes, allowing teams to consult and plan for care in real time. The Viz AI platform demonstrates a powerful clinical impact while reducing length of hospital stay, saving time, and increasing access to care when patients need it most. The Viz AI tool for early stroke detection will increase annual treated large vessel occlusion strokes by 31, which will result in an increased yearly revenue of $3.5 million for the WeHeal Health Network. By utilizing Viz AI new technology add-on payment of $1,040 from CMS, this will result in an increased revenue stream of $1,366,000 for the WeHeal Health Network. And finally, the Viz AI tool will save 66 minutes per patient, reducing the overall length of stay by 2.5 days, resulting in an annual cost savings of $8,240,000. As the stakeholders of the WeHeal Health Network is considering the implementation of artificial intelligence, it is important to understand how to build a successful AI product. May I recommend 5 effective steps when building an artificial intelligence product? First, understand the domain you're targeting. Corporations need to start off by defining the problem, then building the AI product to meet that need, one by one. Secondly, use high-quality representative data when training AI technology. This will ensure that the tool will be unbiased and provide highly accurate and safe recommendations. Thirdly, anticipate that problems will arise when your algorithm meets the real world. Don't assume that if a tool succeeds in one setting, it will work in others. Get ahead of potential problems by debugging your models, performing rigorous error analysis, and evaluating and investing in the stability and robustness of your models. Fourth, manage expectations and learn from errors. It's important for AI systems to offer users clear information about how reliable their predictions are, and to fail gracefully when they are uncertain. And lastly, don't let marketing hype outpace accountability. In a crowded field of competitors clamoring to launch the next big thing, it is essential to clear away the hype and focus on building a great AI product.